Hello and welcome to the Features of Sine and Cosine Day 1 video. In this video, we're going to be going over a lot of new vocabulary for our different trig functions, and then we're going to be looking at either equations or graphs and identifying what these features are, all those new vocabulary words. There's a few things you're going to want to know first. I will not be showing you the parent graphs of sine and cosine in this video. I can give you another video on that, but I would Google that right now, the parent graphs of sine and cosine. I will do just kind of like a rough sketch of a graph right now that we can refer back to. So we'll have it look something like this. Very, very rough sketch. And then next I also want to say what our general equation is going to look like. So it's going to look like y is equal to a times sine or cosine, depending on the function, of b times theta. You can use x, I'm going to use theta, minus c, close all those parentheses, plus d. So right now I just want to go over you what are those a, b, c, d values. They're all going to be new vocabulary words for us, and we'll have one more besides that. So these are all of our features. Let's get started. So first we're actually just going to take a look at D. D is the midline of our graph, or the vertical shift, if you're thinking about transformations. So the midline is a horizontal line located between the maximum and the minimum of a graph. So if we take a look up here at this graph, here's the very top of my graph, here's the very, pretend these are on the same level, this is the very bottom. The midline is going to be in between, so here that'd actually be on our axis. So this right here, horizontal line in the middle of the graph, that's the midline. Next, we're going to address A, because A has to do with the midline, and that's actually going to be our amplitude. And our amplitude is our vertical stretch. So these are hopefully words you've heard before, vertical shift and vertical stretch. The amplitude is the distance from the midline to, the highest and lowest points on the curve. So if you're looking for highest points, you could say our highest point is here, lowest point is here. I'm basically looking for the distance from the midline all the way down, or the midline all the way up. Because the midline is, as it states, in the middle, that distance is going to be the same. So our amplitude is going to be the same whether you're measuring from the middle down or from the middle up. So you only have to measure that once. So the next piece I want to go over is that C part. That's going to be our phase shift, which is also known as our horizontal shift. It really is just a horizontal shift. We just call it phase shift for our trig function. So it's really not super different there. So it just indicates how far, I accidentally muted, sorry. It indicates how far the graph has moved left or right. And something that we would do for a horizontal shift anyway, just remember it moves in the opposite direction of the plus or minus sign. So it just moves the other way that we think. So these three pieces here, a vertical shift, a vertical stretch, and a horizontal shift, we've been dealing with those forever. So like a horizontal shift might be something like, oh, this got shifted to the left. There you go, right? So that's not too bad. It's this part B and another word that we're going to have to identify that makes things a little bit newer for us. So one of those new words for us is going to be the word period. Oh, it looks like I've run out of space. You can see I have a worksheet down here that we're going to work on in just a moment. I wanted to define everything, and I thought I gave myself enough space. I guess we're just going to zoom in and pretend. So the next word is going to be our period. Unfortunately, I only have 5 colors, and so I'm not going to be able to do period in its own color. This is the horizontal length it takes to complete one full cycle. You can also think of this as just how long does it take the graph to repeat itself. So if we go through and we take a look at our graph, oh my goodness, it looks so small. If we take a look at our graph, I can see that if we're seeing how long it takes to repeat itself, well, if we have a point all the way up here, how long does it take to get back to the very top of the graph? So this distance right here, that's a period because it tells us how much of one full cycle we have. Now, with our period comes that b value. Remember, period is not the b value. Our b value is going to be the frequency. So that's the b value. And our frequency, readjust this, is the number of cycles completed in a given interval. Now, because we're looking at one full, I'm doing air quotes, cycle, one cycle might be one full rotation of the unit circle. So depending on whether we're looking at radians or degrees, that cycle is, or pardon me, that interval is usually 2 pi or 360 degrees. So the period and the frequency are related, but the only part that you see in the equation is the frequency. So we will spend some time going back and forth between those. Really quick, kind of an equation I can give for that is that if you are trying to find your frequency, you can do 2 pi or 360 divided by your period. Or if you're trying to find your period, you can do 2 pi or 360 divided by the frequency. So depending on what information you have, whether you're looking at an equation or you're looking at a graph, you can use this equation. So anyway, those are our different features. I feel rather unfortunate I didn't leave myself enough room, but that's okay. Let's go through and take a look at an equation and a graph, and let's try to just identify these features. We're not even going to try writing an equation. So let's take a look right here at this very first problem. So this is just the first page of the blank notes is what we're looking at. Part 1 says, identify the midline, amplitude, period, frequency, and phase shift, so all the things we just talked about, for each sine and cosine equation, and explain what each part does for that graph. So let's take a look right here. I'm just going to zoom in on this part 1. Oops. There we go. So remember, we're going to have, oops, that's the wrong color. Y is equal to A times, in this case, it's a sine function, of B times X or theta minus C plus D. So when we're looking for our midline, that was that D value. So our midline is at 4, means that the graph moves up 4 from the parent function. Okay, not too bad. That's something we've dealt with before. Next is the amplitude, or that number out in front, which in this case is 2. Now, you can think of this as the distance from the midline, but remember, this is also our vertical stretch, so you can think of it in that way. Period, we don't have a specific color, but I'm going to give frequency first because we actually have our frequency in the equation. The frequency is that 3. So that tells us that in a period of 360 degrees, or in an interval of 360 degrees, we're going to have 3 cycles. So remember, we're going to either be looking at 360 if we're looking at degrees, which in this case we are, or 2 pi. So because that was our frequency, I'm going to be using this equation we have here, kind of in the upper left-hand corner, where it says period is equal to 2 pi divided by 360, divided by frequency, or in this case, it'll be 360, because that's our total cycle, or total interval divided by our frequency of 3. So that's going to be 120 degrees. So it takes 120 degrees for 1 cycle. So again, the period itself isn't in the equation, but you still need to find it. The very last thing we have here is our phase shift, or remember, you can think of that as your horizontal shift. This is going to be 45 degrees. So even though it says minus 45 degrees right here, just remember you need the opposite sign. So even though the equation said minus 45 degrees, we're just going to say the phase shift is 45 degrees, or it's, there's a shift to the right, 45 degrees. So this is kind of like when we would go through and look at transformations and say, hey, list the transformations for me. What's happening? Well, we just now have new words for our transformations. But this is what happens if we look at an equation. What if, for our last problem, we looked at a graph? So let's take a look at problem number 3. Now, we're not going to do all of problem number 3, specifically because the last 2 pieces ask us to write equations for sine and cosine. We're not doing that. Right now, we are just identifying features. So we take a look at the instructions here. It says, identify the midline, amplitude, period, frequency, and phase shift for sine and cosine. So there's a different horizontal shift depending for each graph, and explain how you know. So first thing, let's take a look at our midline. Well, if we're all the way up here at 10 and all the way down here at negative 10, in the middle, we're going to have 0. So this line in the middle, that's my midline. And that's going to be 0 because it's between it's between the top and bottom of the graph. So that's the midline. Next we have our amplitude. Remember, amplitude is the distance either from the midline to the bottom or the midline to the top. Oh, I haven't been highlighting these. There we go. So next we're going to have amplitude. So I'm going to do over here, so from my midline all the way down to the bottom. So even though we're moving downward, it's still a distance of 10. Your amplitude will always be positive. In this case, our amplitude is 10, and again, this is the distance from the midline to either the bottom or the top of the graph. Next, we have the period. The period here is actually not so bad. So we're just looking to see how long it takes to repeat itself. Now, I see we have a spot all the way down here at the bottom. We have a spot all the way down here at the bottom. So I'm going to look for this distance. Now that distance is not -10. I'm looking from this x value of, what is that? -2 pi all the way to over here at 2 pi. So that total distance is going to be 4 pi for one full cycle. So that total distance is 4 pi. Now I want to know for my frequency, how much of our cycles do we have in an interval of 2 pi? So if we think like from 0 to 2 pi, how much of that cycle or how much of that period do we see? Well, we can say that out of 2 pi, our period is 4 pi. So we're going to take 2 pi, divide that by the period, and we end up with 1/2, meaning that we get through 1/2 of cycle in an interval of 2 pi. So we can see that we really only have the top to the bottom part. We don't get one full cycle, we just get this half of it. So our frequency is only 1/2. So those are kind of the features we have right now. We also have our phase shift. Again, I haven't really gone over the parent functions for sine and cosine. Please make sure you look that up. But we're going to be looking to see, hey, how far did this move from the y-axis? Well, you can pick any point you want. Just usually pick one closest to the y-axis. Now, if you take a look at your cosine graph, here these are going to be in green. It's going to be different for each of these. If you take a look at your cosine graph, cosine has a y-intercept at the very top of the graph, just like we have right here. Well, if we already, right now, have a point at the very top of our graph, I'm going to say cosine didn't shift. It wasn't anything. And again, that's because cosine starts at top of graph. Whereas for sine, sine moves up through the midline. So I need to pick a point that moves up through the midline. So I can either look here or I can look here. Either of those places will work. We cannot pick this line here because it's moving down through the midline because we read a graph from left to right. I'm going to take a look at this one here at -pi, since that is the closest to the y-axis. So this is all the way out here, or this is for sine. So that went out all the way to -pi because sine starts moving up through the midline. So I know that's a lot of information of what we've done today. It's a lot of new vocabulary words. Don't worry about writing equations yet. We'll do that on day 2. So rewatch the video if you have to. Let me know if you have any questions, and I look forward to seeing you in class.